Hi guys, these are our notes for finding zeros we did on Friday. This is going to go into your digital notebook when we're done. You can fill in your table of contents, slide 10 and 11. Today is going to be finding zeros. We're actually not going to be able to finish all of them today. Some of it we're going to fill in on Monday as well. Okay, so at the top of your paper, you want to go ahead and title it. So remember, you're just handwriting everything on a sheet of paper, and then afterwards we'll put them onto the slides. You do not need to write down the essential question, but title your paper Notes 2A.3.3 Finding Zeros. What you should be able to answer at the end of our notes is what do polynomial zeros mean on the graph, and how do you find them algebraically? Okay, so we're going to look at the remainder theorem. That's how we're going to find some zeros. So we solved quadratic and cubic equations by factoring, but we have another way that we can solve cubic and higher level problems as well. So the remainder theorem says, make sure you write down the remainder theorem. The remainder theorem says that x minus a, binomial x minus a, is a factor. Remember, a factor is something that divides in evenly. A factor of a function f of x if and only if f of a equals 0. So x minus a is a factor of a function, so that means it divides in evenly if, when you do synthetic division with the a, then you get 0 in your remainder box. Okay, so in other words, write it down, in other words, if you perform synthetic division, and get a 0 in the remainder box, then that number is a root 0 solution answer x-intercept, all those things mean the same thing, and x minus a divides in evenly. So that's what the remainder theorem says. So basically, if you do synthetic division, you can get a 0 in the remainder box. It means that that number that you used with synthetic division is a root, a 0, a solution, an answer, an x-intercept. They all mean the same thing. So we're going to talk about how to find them. So how do you find the roots? We're not going to graph it, so we're not going to look at the graph. Instead, we're going to have to, for now, we're going to have to use a guess and check. You're going to use the numbers -4 to +4, trying to plug them into synthetic division. Until you get a 0. If those 9 numbers don't work, then you can go on to like -5 and +5, -6, +6, and try those numbers. But you have to do guess and check for now. You're just going to repeat this process until the depressed polynomial is a quadratic. Then solve that using factoring or quadratic formula. Okay, so we're going to go do a couple of examples of this. So the way that we find zeros using the remainder theorem is we use synthetic division. When we get a 0 in the remainder box, we know that number is a root, a 0 solution, an answer, an x-intercept. They all mean the same thing. And then if they, in order to find what gives us a 0 in the remainder box, we might have to do guess and check. Okay, so we need to go to our Unit 2A workbook. We haven't worked out of the workbook in a little while, but this is officially a Math 3 lesson. I believe it's on page 91. So you want to go to your notebook and go to page 91 should be your examples. So we're only going to do 2 of the 3 examples today, and then one of them we'll save for Monday. So example 1 says, given the equation x cubed plus 4x squared minus 3x minus 18 equals 0, state the number and types of roots of the equation if one root is -3. So we're in luck. They gave us a root. We don't have to do guess and check because they gave us a third degree polynomial. They gave us a root. The depressed polynomial will be quadratic, and then we'll be able to do factoring or the quadratic formula. Okay, so if you guys remember how synthetic division works, they gave us the root. They say the root is -3, so that's what we put in the little box. And then we look at our coefficients. I have 1x cubed, 4x squared, -3x, and my constant's -18. I don't need any 0 terms since I didn't skip any of my exponents. Then you move down the first number of 1. So if you recall synthetic division, we did this in our last unit. You multiply by the number in the box. So -3 times 1 is -3. Add coming down, that's 1. Multiply by -3, that's -3. Add going down, that's -6. Multiply by -3, you add, you get 18. Add coming down, you get 0. Okay, that just means that the remainder is 0. That means -3 is a root. We already knew that. They told us that. Well, what we have now is we have a depressed polynomial, because remember the number next to the remainder is a constant. The number in front of that goes as a coefficient on x and a coefficient on x squared. So what we're going to do is we're going to try to factor the depressed polynomial to find the remaining factors. Okay, so our depressed polynomial is 1x squared, so x squared, plus 1x minus 6, and then it's equal to 0 because the original problem is equal to 0. And we're just going to solve this by factoring. So we're going to use Snowflake. This is the easy Snowflake because your a value is just 1. 1 times -6 is -6. B goes on the bottom, that's the number 1. And then it's just x and x because there's no a value. So what number multiplies to -6 but adds to 1? Well, the numbers that multiply to 6 are 1 times 6 and 2 times 3. Since it's a negative on top, one of those numbers has to be negative, so it's going to be 3 and -2. So I factored it to get x plus 3 times x minus 2 equals 0, and then I just go ahead and solve both of those. So to solve them, I get x plus 3 equals 0, x minus 2 equals 0, and we get x equals -3 and x equals 2. There was one other root, the one they gave us. They gave us -3. Well, we already wrote down -3 as a root, so we have 2 real roots. So remember it's a cubic, so it's going to have a root at -3 and at +2. And I don't know exactly what it looks like, but I bet it looks something like this, if I had to guess. It's a cubic, so it has a little S-curve. It only hits the graph once, or twice, I mean. Okay, we're going to do one more example for today, and then we'll get these put into our notebook, okay? So, well, not fully, but you'll see. So example 2, it says find all the zeros of the function x cubed plus x squared plus 11x plus 51. Verify your zeros by creating a graph. So we could check by using a graph. All right, well, they didn't give us one. Okay, they didn't give us one to start with, so we have to do guess and check. Okay, so I always just start with the numbers -4, and then if that doesn't work, I go to -3. If that doesn't work, I go to -2 and -1 and keep going. So my coefficients are 1x cubed, 1x squared, 11x, 51 is my constant. I don't need any zeros because I didn't skip anything. And then I move my first number down, that's 1. -4 times 1 is -4. Add, I get -3. multiply by negative 2, I get 12. Add coming down, I get 23. Multiply negative 4 times 23, I get negative 92. Do I get 0 in the remainder box? No. So that means negative 4 is not a root, a 0 solution, an x-intercept. It's not those. Okay, so we'll try another number. We'll try negative 3. So I use my same coefficients, 1, 1, 11, 51. So I'm trying to get 0 in that remainder box. So I move down the first number 1. Negative 3 times 1 is negative 3. Add coming down negative 2. Multiply by negative 3, 6. Add coming down 17. Multiply negative 3 times 17 is negative. 3 times 17 is 51. Add coming down and I get 0. Yay, that's a good thing. When you get 0, that means that you have found a root. So negative 3 is a root. Okay, negative 3 is a root. We're going to use that. Then we're going to use our depressed polynomial. So remember, this is the remainder, this is the constant, coefficient on x squared. So we have 1x squared minus 2x plus 17 equals 0. So I always try to factor, okay, what two numbers multiply to 17 adds to negative 2. Well, it's not factorable. That doesn't work. That doesn't mean we can't solve it, right? Instead, we have to use the quadratic formula. So we're going to use x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. So this is on the back side. I forgot to mention that, but it's on page 92. Hopefully you guys are able to find it, example 2. So my A is the number 1, my B is negative 2, and my C is 17. So x is equal to negative, B is negative 2, plus or minus the square root. B is negative 2 squared minus 4, A is 1, times C is 17, all over 2 times A, which is 1. All right, I might run out of room, so I get x equals negative 2, subtract a negative 2, that's positive, plus or minus the square root. Negative 2 squared is positive 4, and then you multiply negative 4 times 1 times 17. Negative 4 times 1 is negative 4. Negative 4 times 17 is negative 68, all over 2. So underneath my radical, if I do 4 minus 68, I get negative 64. Well, when you square root a negative number, what does that mean? It means that it's imaginary. So you put the I on the outside and you turn it positive. Do I know the square root of 64? Yeah, it's 8. So I actually get 2 plus or minus 8i over 2, which you can simplify that because the 2 over 2 can be simplified and 8 over 2 can be simplified. So it's actually going to be 2 divided by 2 is 1, plus or minus 8i divided by 2 is 4i. So that's two answers. We get 1 plus 4i, 1 minus 4i. I'm just going to erase so I don't have to write it twice. We have two answers, 1 plus 4i, 1 minus 4i, and we also have that real root that we found, negative 3. So we have 3 answers, 1 real, 2 imaginary. So what that means is that if you graphed it, it's only going to hit the x-axis 1 time. These roots, zeros, solutions, answers, they all just mean the x-intercepts. Those x-intercepts are the answers to the graph. Okay, so we're not going to do example 3 today. We're going to do that on Monday. So what you need to do is you need to put the notes part that we wrote down on slide 10 on the left. This part we don't have yet. So this we're going to get on Monday. We don't have that part yet. Then you can put page 91 on the right-hand side of slide 11. You don't have to put this one in yet. We're going to put it in on Monday, the example 2, because we still have to do example 3, so we'll put it in the slide on Monday. But you can put in 2 pictures right now. You can take a picture of the notes part, goes on slide 10 on the left, and then your picture of page 91 from your workbook, and then put it into your digital notebook on slide 11 on the left-hand side. And so we'll take 2 more pictures on Monday to put in after we do example 3. Okay, and then your homework tonight is, I think, 5 problems like example 1 and 2. So you have a couple problems where they give you a root, you find the depressed polynomial and then solve it, and then you have a couple where you have to do guess and check.